We've seen that unexpected or unwanted user input can cause problems with our program. In other languages, we might say that the code throws an error. In Python, we say that it raises an exception. Let's code up a quick example here. So our little program here has a simple quiz, and we run it. We can have all kinds of fun with this. We can get the right answer. We can get the wrong answer. Or we can totally mess with the computer. In this case, our code raised a value error exception. Remember that the input function returns a string. Here we're trying to convert the string into an integer, but the Python interpreter doesn't know what to do with the word 8. The int function can only handle strings that are composed of numbers. And as much as we'd like to think that our user will be savvy enough to use numerals all the time, we need to protect against this. We could do that by first checking whether the string is actually a number. And we see that this actually works. But the more Pythonic way to do this is to actually let the error happen and then deal with it when it does. We call that exception handling. So let's back up and first recall what kind of exception we got. So we need to be able to catch a value error exception when it happens. And we'll do that with a try except block. First we say try, and it really means try this. We want the interpreter to try to change quiz answer to an integer. If it can't, then it should jump to an except block. This line means that if the try block fails because of a value error, then we want to execute the following code. If it doesn't fail, we can go to our familiar else block. So to recap, we're going to try to do this. If we fail and receive a value error, we're going to jump to this block. However, if we succeed and convert quiz answer to an integer, we go to the else block. Let's run this. First, I'm going to try giving the program a valid answer. Seems to work fine. And then let's type in a word. And this time the error was caught. So we have a try block, an except block, an else block, and we can also have a block called finally. The finally block is executed whether or not an exception is thrown. In many programs, you'll see a try block and an except block, but never an else or finally block. Remember that any code without further indentation is going to be executed anyway. Let's change up our code a little bit. Here's a program that tries to evenly distribute jelly beans. We have 250 jelly beans. We want to find out how many people there are and let you know how many jelly beans you should expect. We'll do that by dividing the 250 jelly beans by the number of people. So we run the program. If there are 50 people, you should get 5 jelly beans. We are allowing you to get fractional jelly beans. If we use a word instead of a number, again, an exception is raised when Python tries to convert the word into an integer. So that's great, but what if the user says there are 0 people? Of course, we get an error because we cannot divide 250 by 0. This is a different error, though. This is a 0 division error. There are several ways we could handle this. Of course, we could use an if statement to check for 0, but we can also use another try except block. This time the error we expect is a 0 division error. We write code to handle the zero division error, and also code that gets executed if everything is okay. We'll make sure this works. Perfect. This is a good way to handle this because we always want to put as few statements inside the try block as possible. But on the other hand, now we have layers of indentation that gets a little confusing to look at. There's another possibility that will address this problem. We can take both of these lines and place them inside the try block. We'll remove the indented try block and unindent the remaining code. Now we have one try block, but within that block we have the potential to raise two different kinds of errors, a value error or a zero division error. And the code that's executed depends on which error was raised. Or, of course, the code in the else block would be executed if there were no errors. So let's try this again. First, I will put in a legitimate answer, then a word, and finally 0. Python successfully caught both of the errors. Note that we can also add a third except block that'll catch any other error that happens. However, PyCharm doesn't like that. It says too broad exception clause. And the idea is that exceptions should not protect you from sloppy coding. You should test your code well enough to know that you haven't introduced any bugs. But sometimes we can anticipate some bad user input, or maybe a missing file, or a web page that doesn't load. And in those cases, we use the exceptions to handle those anticipated but unwanted cases. So we'll take out our too broad exception. We can even create our own exception types and raise them within our program, but we'll do that later in the course.